Good morning, I'm Mahiti Kandukuri. I'm dialing in from Dubai, and today I'm going to be giving you a very brief overview of my research paper, which was about shift work and its impact on circadian rhythms. My mentor for this project was Joanna. So circadian rhythms, to start with, are 24-hour body cycles that are controlled by the suprachiasmatic nucleus in the brain and various body oscillators. They have 5 properties: self-sustained, last approximately 24 hours, are ubiquitous, conserved, and they also have the ability to be entrained by external factors or otherwise known as zeitgebers. And the most powerful zeitgeber is light. So the ability of light to induce a shift is due to the presence of IPRGCs that detect light through the protopigment melanopsin, signaling SCN and controlling melatonin release from the pineal gland. Despite species differences, the genetic process controlling circadian rhythms are fairly similar and operate in a transcriptional translational feedback loop. This includes a positive arm, a negative arm which restarts the cycles, and in the case of mammals, multiple MPR proteins that have specific roles. It is estimated that 0.7 billion people all around the world are engaged in shift work of some sort. And shift work involves any shift where a portion occurs between 7 p.m. and 6 a.m. that conflicts with the natural sleep-wake cycle. This results in desynchrony between the work cycle and natural circadian rhythms that are similar to jet lag, leading to sleep and wakefulness problems. Along with sleep and wakefulness problems, this could also have multiple adverse effects on many different organ systems, which a few of them I'm going to be talking through during this presentation. So number 1 is cardiovascular system. SCN, or the suprachiasmatic nucleus, controls the cardiovascular system, regulating the blood pressure and the heart rate. Indirectly, it also affects the cardiovascular system by synchronizing cardiac tissues to act as peripheral tissue clocks. Circadian misalignment in humans during night shifts also led to increased wake time blood pressure, 24 average systolic and diastolic pressure. It also decreased the healthy sleep-associated systolic blood pressure dipping effect, increasing the risk of CVD. Male workers in rotating shift work had 2.32 times higher risk of ischemic heart diseases compared to daytime or fixed nighttime workers. Number 2, in the nervous system, circadian dysfunction is linked to a higher risk of brain disorders, including psychiatric conditions like depression. Shift work also leads to decreased and impaired sleep, contributing to cognitive problems like reduced alertness, concentration, and increased reaction time. Sleep deprivation may also impair cognitive functions by affecting specific brain areas, particularly the prefrontal cortex. Weak circadian rhythms and fragmented activity patterns in older adults are risk factors for dementia. Individuals with Alzheimer's exhibit lower melatonin rhythm amplitudes and disturbances in the sleep-wake cycles. Lastly, disruption of circadian cycles also increases human error rates due to slower reaction times and decreased attention span. Industrial accidents like Chernobyl and 3 Mile Island occurred at night, with shift work and human error as major contributors. So you may ask, with shift work having so many negative impacts on the human body, yet being so useful and so vital to the daily functioning of society, how does one balance between both of them? There are various countermeasures, and most of them focus on fixing the misalignment between the intrinsic circadian rhythms and the external light-dark cycles. And treatment focuses on reducing this misalignment, often through light exposure, which is the most powerful zeitgeber. Laboratory studies have shown that significant circadian phase shifts with bright light exposure 3 to 6 hours before the circadian nadir. Exogenous melatonin can also have the same effect, but is less potent than light, and poorly timed light exposure can often negate melatonin's effects. Another way to sort of decrease the adverse effects is to also increase sleep quality. This reduces issues related to insufficient sleep. Simple sleep hygiene practices include avoiding alcohol and caffeine near bedtime and creating an optimal sleep environment. Drugs like exogenous melatonin, ramultion, and tazimultion can improve sleep in shift workers but require controlled light exposure to be effective. There might be side effects associated with these drugs that include dizziness, fatigue, nausea, and increased prolactin levels. That was the end of my 5-minute presentation. I'm sorry, I wish I could go into more depth, but that will have to do for now. If you have any questions, please be free to send them over to me and I'll be most happy to answer them. Thank you for listening to me and have a great day.